Good morning, eighth graders. So we are focusing in on eclipse and tides today. Tides is not necessarily a part of your standard, but eclipse for sure are. But it's kind of hard to not talk about tides with all of this, just because the sun and the moon play such a huge role in creating our daily tides. So we're working with middle school Earth Science Standard 1-1, which states that you'll develop and use a model of the Earth, Sun, Moon system to describe the cyclic pattern of lunar phases, we covered last week, eclipses of the sun and moon, which we're covering this week, and the seasons, which was 2 weeks ago. So you are going to be able to, first of all, define the types of eclipses. There are 2 different types, plus then within there's like 2 other types, so technically 4. Describe how the Earth, Moon, Sun positions impact eclipses. Clearly, we don't have eclipses every day, and there is a reason for that. And then identify the different parts of the eclipses. So we have 2 major key terms that we need to understand, which will help play into understanding more about eclipse. So, this is the kind of morning. Eclipse. So when the Earth or moon, obviously we know that there's a difference between a solar and a lunar eclipse, cast a shadow on one another. So the sun doesn't move, but the Earth or the moon have to move, and then depending on who's in what order, that then determines what kind of an eclipse we could see. So first, let's talk about solar eclipses. This is when the moon's shadow appears on Earth's surface. So the order has to be sun, moon, Earth. So the moon gets caught in between. This can only happen during a new moon phase. Now, if you think about it, it can only happen during a new moon phase because if you think of how our lunar phases work, it has to go sun, moon, Earth in order to have a new moon because the side of the moon that's being illuminated is facing away from us. So that. Now, a lunar eclipse occurs when the moon moves into the Earth's shadow. So then the order is sun, Earth, moon. This then can only happen during a full moon phase. So again, because of how we know our lunar phases have to occur in order for the correct side to be illuminated, it has to be sun, Earth, moon in order for the moon to be fully illuminated so that we can see it. FYI, there is a full moon tonight. Now, once the object moves into the path of the other, so whether that is the moon casting the shadow onto the Earth or the Earth casting the shadow onto the moon. There are 2 different parts to an eclipse, and this then tells you whether you are in a totality of an eclipse or a partial. So the umbra and the penumbra, very Harry Potter-esque, but I don't even use that as like my examples. So the umbra is the central dark shadow where all light is being completely blocked off. I like to think of it as like you are sitting under an umbrella where you are not getting wet. You are within the frame of the umbrella, so it's blocking you from the rain. So the umbra, if you take a peek down at, let's see what color is going to show up the best. Let's do yellow. If you look down at this one, the umbra is all of this dark phase here. So this is all your umbra. This is where you're going to get a complete blockout of the sun on either the Earth or the moon. Okay, then you have the penumbra. So this is like the partial umbrella, which is the outer shadow where sunlight is able to kind of peek through. It's only partially blocked. So if you look here, it is going to be on either exterior portion of the actual like eclipse. this top picture is kind of good to know. We'll talk a little bit more about that here in a bit, but obviously if you look at the different sizes between the sun, which is totally not to scale, and the moon as compared to the earth, and we are not that close to the moon, you can see how small of a shadow of totality is actually made with the umbra versus the penumbra. So that then brings me into the difference between a partial solar eclipse and a total solar eclipse. Now, you really only get partial and total when it comes to solar eclipses rather than lunar eclipses. And again, we'll talk about that here in a moment. So this is from the 2017 eclipse that passed through North America, in particular the US. So, during a solar eclipse, only people who are within the umbra will be able to see the complete total eclipse. That is where you have to wear glasses, you have the sun and you have the moon, and you see just like that outside corona of it. People who are viewing from the penumbra are only seeing a partial eclipse. This is where they are not able to take off those sunglasses in order to protect their eyes. Because only part, like a large part typically, of the sun is completely blocked out by the moon. Now, if you get an opportunity to see this, please see it. In 2017, I was very lucky, childless, very lucky to be able to just hop in my car last minute and drive down to Grand Island, Nebraska with Mr. G and one of our friends to be able to witness the total eclipse, and it is amazing. Now, granted, it was also in the middle of summer, so it was nice and warm outside, but it is an experience that it's hard to describe. So if you get an opportunity to see a total eclipse, please go see a total eclipse. It is amazing. So, just a little thing. This is from the greatamericaneclipse.com. Basically, for the next 100-some years, when we are going to see when we're going to see some total solar eclipses over North America. So obviously the one that I was able to see was this August 21st, 2017 one. Then if you kind of take a peek around, you see we have a total solar eclipse that'll eventually go over West Fargo, North Dakota. It's in 2099. So y'all have a really good chance of still being around. Real old. I probably won't be around for it, but Mr. G and I are already trying to plan whether we can make the 2024 one work and head out probably to Southern Illinois, but maybe we'll make a whole trip of it. But then the 2045 one in August, just because it goes through where we both were born and our grandparents are at. So super duper fun. But yeah, so if you're able to stick around until 2099, you won't even need to step out your back door if you stay in Fargo. So, which is amazing. The 2044 could be kind of cool too if you wanted to take a quick little trek out to, you'd just be catching the very end of it, but that'd be kind of cool. So this is fun. If you want to screenshot this, go for it. It's kind of fun to think like, hey, maybe one day I could just be at a total solar eclipse. So this is the time where if you're just here for the whole group notes, fantastic, see you later. Make sure that you keep your voice level at a 0 or a 1. Your activity is completing your notes today. Find a spot that works best for you, and then, oh my goodness, and then you're able to kind of move on, okay? You guys know what the game plan is. If you're sticking around for the rest of the PowerPoint notes, you're in the right place. So why don't solar eclipses happen every time there's a new moon? We have talked about how the moon is on a 27.3 day cycle. So why is it that we're not seeing a solar eclipse every 27.3 days? Wow, that is because not only are we at that slight angle of the 23.5-degree tilt, but the moon is on a 5-degree tilt from us. So there is always a solar eclipse once a month. It's just whether the shadow is then being casted upon the Earth or whether it's going out into space. So that's kind of the difference. So we do have one happening all the time, but most of the time, like if this were the case in this picture, you have the shadow of the Earth kind of coming this way. So you can see that the moon up here, it's even out of the penumbra of it. So it's not always going to be visible. It's going off into space rather than onto the object. So now let's talk about lunar eclipses. Solar eclipses are the big ones. These are the ones that everybody wants to like see, and it's going on and it's really cool. Lunar eclipses are a little less wow inducing. So this occurs when the moon moves into the Earth's shadow. And obviously you can tell from this picture, the Earth's shadow is really, really big versus how itty bitty the moon is. So this can happen a little bit more easily, and it can happen just a tish more regularly. So similar to the solar eclipses, you have the total and the partial. So total solar eclipse is when the moon moves completely into the Earth's umbra, and this is where you get it completely like darked out. Now, the thing is though with lunar eclipses versus solar eclipses is that it doesn't go black. The moon gets this really cool, creepy red haze to it. Now you can see that the shadow does kind of come in, but it's not as wow inspiring as a solar eclipse. The partial eclipse, again, it looks just like you would think our moon phases to be, but it happens in one evening. So where part of the moon is being blocked off, not the entire part. So, lunar eclipses can only happen during a full moon. Again, we have to remember the difference between where our moon has to be in relation to our sun in order for this to happen. So it can really only happen during a full moon phase. Now, lunar eclipses, I don't want to necessarily say that they can happen more often, but they can essentially happen more often just because, again, of how large the Earth's shadow cast is as compared to the lunar shadow cast. So our next opportunity is actually coming up in a couple weeks. So we have a total lunar eclipse occurring over the northern hemisphere on November 8th, 2022. Now, I'm looking at my cool little map thing on my phone. I can't see that because it just doesn't work that way. But looking at it, and we will be in a position in North Dakota to be able to see all of the total and some of the partial visibility. So we will be able to see the eclipse through and through versus some places, the further south you kind of get, you will really only see some of the penumbral eclipse. But it covers a wide range. I want to say this is probably mid-Montana all the way to Japan gets the entire eclipse visibility. So you can see that that's a big deal. And again, it has a lot to do with how large the Earth is in comparison to the moon. So these are a little bit easier to view except for the fact that it happens typically between midnight and 5 a.m. Just saying. So, but November 8th, 2022 is our next lunar eclipse, which is really, really cool. And these are ones, again, that typically you're able to just walk into your backyard and you're able to see what's going on. Tides. So like I said, it's really hard to talk about the Earth, Sun, Moon relationship without talking about tides. Now, the reason why we as a team decided like tides are important, but they're not important enough for us to be like, you have to know this. So none of this will appear on your assessment. But tides are important because these are the daily rise and falls of our oceanic levels, so our sea level. And this is due to the difference in strengths of the moon's gravitational pull as opposed to the Earth's gravitational pull. And even then, you get the sun involved in all of this. So you can see by the picture in here, the moon is perpendicular with the Earth, and as the moon pulls on the Earth's gravitational force, all the water on that side wants to pull with it. Now, typically then, it's like if you were to take like a piece of slime or something, like you have to pull from both sides. Why 100% does this happen? Typically, it's because of the way the sun is positioned, things like that. So you have to pull from two sides. Sometimes they're wonky sides, whatever. So, wherever the moon is, typically that side of the Earth is what is in what we consider high tide, and then the complete opposite side. Versus the sides that are perpendicular, because you're stretching on this, the inside kind of like squeezes down because you're pulling it all out towards the outside. So that is then what we consider to be in low tide. So the sun can also have an effect on tide, but it's much further away, so it doesn't play as large of a role. So you can see in this example, you have the sun, the earth, and then the moon in this perpendicular pattern, and you can see that the tides are not nearly as high. So the sun, depending on where the moon is, can either help the moon to its advantage by creating higher high tides or lower low tides, but then it can also kind of sort of just chill it out to where high tide is highish and low tide is lowish, but nothing truly changes. So that brings us into two key terms. Now, I know all of you are like, I'm never going to leave North Dakota. Well, some of us might, and some of us might move to a place where there are tides, and you have to understand when the meteorologist comes over the news and says, oh, we're in a spring tide, or oh, we're in a neap tide. This plays a lot into how you're able to use watercrafts and things like that. So the position of the sun and the moon affect the tides together. So spring tide. Typically, this is going to happen during a full or new moon phase. Again, remember, sun, earth, you have to have either the moon in between the two for a new moon or a moon on the other side for a full moon. This produces higher high tides and lower low tides. Now, why is this important? Well, if you have a boat in the marina, you can take it out during high tides because you have no concerns about hitting the bottom of the marina seafloor with said boat. But lower low tides means you might actually be landstuck on those boats and whatnot because the water has sunk so low that you're just not able to get it out of the sand. Then you have neap tides. Typically, these happen about a week after spring tides, and this is where the moon's earth and sun form a 90-degree angle to create high tides that are low and low tides that are kind of higher than typical. So it's like you have high tides-ish, you have low tides-ish, and This is really nice because now fishermen don't have to worry about their boats getting stuck because for the most part, low tides aren't low enough. But high tides aren't super duper high. So it's just dependent on kind of what marina you're in, what you're trying to do, and when you're trying to do it. So this is what neap tides versus spring tides would look like, and you can kind of see the different pull that the sun versus the moon have on the earth and its waterways. So tides are great to know. You have to know eclipses. So if you have any other questions, please let me know. Make sure your notes are completed and they're turned in. There is an exit flip. Yeah, that's all I got right now. So yeah, thank you so much and we'll chat later. Thanks guys.